What is up, everybody? Welcome to CS202 Online, Day 2, or Video 2, shall we say. Hope everybody's doing good today. So, today we're going to continue where we left off yesterday, which was talking about classes. Thank you. Yeah, we got to 300. Now we got to get to 1,000, because I think that's when you can do mobile streaming on YouTube. And that's my goal, because then I could actually stream from the fall, like from campus, like the class, on the tablet directly, and then have like remote learning that way. But I don't know. I don't think we're gonna be able to get that by the fall. So I mean, I can always try to do Twitch on the iPad directly. Maybe that'll work, you know, so that people that are at risk can take the class from home, and then people that want to be on campus can be on campus. So you just lost 600. Yeah, that's probably because you use one of the other options there. Like you use a hydrate or one of those things, and maybe that's why the points were gone. Once you use them on something, they are taken forever. So only use them on the extra credit unless you are feeling generous and giving away your points. So yes, ask me on Discord later. I can explain that. But anyways, so today we are going to continue into the idea of object-oriented programming and achieving that using classes. And what we're going to focus on learning today, which is basically what we finished last time, was we were just introducing the idea of public and private variables. So in classes, so that's what we are going to continue from today. And then the solution to dealing with private variables, which are using getters and setters, which are also known as accessor and mutators. I'll also talk about another way that you can initialize your class variables using a constructor, and a destructor, which is something that runs at the end of your class per se when it goes out of scope, which isn't really used yet. It will be used more when we talk about dynamic memory allocation. So we will revisit that topic, but I'll still, introduce it. We will also talk about static variables finally, because I just want to get that out of the way. Plus, I think it's actually in assignment 2, so might as well put it in there. And I think that's going to get us to the end of the class. But if not, there's tons and tons of more things that we could talk about. So without further ado, let's go ahead and open up the code. Ooh. So this is what we were coding last time. This yeah thing or whatever. Let's see, what were we doing with this stuff? So we had an anime class, and then we had default values for it, but we didn't have to. So in fact, let's go ahead and get rid of the default values of this thing. Okay. So now we got name, good guy, bad guy, sidekick. We got a print function, and we got a speaking function, which is good guy speaks. Good guy speaks is a function that basically says the name of the good guy, colon, and then the string that he's going to speak, because we're writing our anime, I guess. And then we got a print that prints out. I think print should be renamed into something more meaningful, like maybe print cast list. I think that's probably a better one. So print cast. Yeah, let's do print cast. So we got to rename it here as well. Okay. Great. Except now we are creating this DBZ, Dragon Ball Z anime, but it doesn't have anything in it. So let's actually see what happens if we try to call print on the DBZ anime. And we don't have anything in it. Yeah. Remember to call functions inside your class. You're going to use the period, which is the member access operator. And then in this case, I guess we renamed to print cast. Oh, because we renamed the print cast, everything else is going to give out errors. So we got to update that. There is a find and replace that you could use as a shortcut. It's usually, I think, Control H or Control I. Nope, not Control I. Control J. Oh, hey, there's a terminal. That's how you get the terminal going on this. All right, I'm going to close it though, because I need all the real estate space. And then Control G, maybe that. Yeah, Control. Nope. I get. Oh, in Control F, maybe I can change the settings here. I don't know. Oh, toggle replace mode. Yeah, here we go. So if I wanted to replace, for example, what could be a good thing to... Well, I kind of replaced already all the prints. I think I did. In fact, that's going to cause problems now if I replace it, because it's going to say print cast. But what could be a cool thing I could use to find and replace? Let's say that I want to put SpongeBob with a capital B. So what I could do is I could say find all the SpongeBob, and I know you can't see the edge of that, so here, let me move that over and replace that with SpongeBob. Well, yeah, Control F allows you to search, but then I click the little thingy here and it switched to replace mode. And then I want to caps lock it. Match casing, there we go. And then click on replace all, and when I do that, it's going to replace all the SpongeBobs with the capital B. So bam, I hit it, and now look at that, they're all replaced. So just a little side track kind of thing to show you that it's a little nice little feature, find and replace. It's very useful when you're coding and you want to update variable names. That's probably the better way to do it than to manually do it. It's just, especially if you got a lot of function calls to it. But anyways, let's just see what happens when we try to compile this. Oh, we still have one thing that was initialized. That's okay. We'll let that one be. Okay, so as you can see, the Dragon Ball Z anime doesn't have anything in there because now we don't have it initialized, right? So I just want to make sure that you understand that if you don't initialize something either using the equal method or the constructor, which I'll show you today, the variables don't have anything in them. And not just that, but they might have garbage in them as well, which is even worse, okay? So just beware of that. By the way, I tried looking up where the Ayaya anime was called, but I could not find it because I was, curious. But oh well, I know the meme, but I can't find it. Anyways, so okay, so now the last thing we did was we made lines private, okay? And by making lines, why did we do that? Because what we were talking about in our example here was we want Kiniro mosaic. Okay, I'll have to remember that. Post it on Discord, I guess. Okay, so yeah, we had, I was just trying to understand why I put gears on that, but I remember now it was a function, so that's what I was trying to get at too. So, and I did a video on this in 135, so if you can always rewatch that, and maybe between this and that, it'll make more sense. But ultimately, the private variables, again, we're trying to keep away from prying hands to mess with them, right? But sometimes, we want a variable to be like read-only per se by the public, by the people outside of the class. We want them to be able to access information from that variable, but we don't want them to modify it. So if we make it private, we're blocking them from both reading and writing to it. If we make it public, we basically allow them to read and write to it. So what if we only want one or the other? Well, typically, you don't just want them to write and not read. That's very rare because that'd be kind of weird because then you don't even know what's in there. But what is more of an actual scenario is you are able to read from a variable, but you can't write to it. Such is the cases with the lines variable that we want. We have a lines variable that is going to keep track of how many lines each character has spoken. And so internally, we want to modify that variable every time we call the good guy speak function. But we don't want people to accidentally change that and screw up the counter. And so it could be useful to be able to print out how many lines have been spoken in main without, directly. But if we make it public, we risk somebody accidentally modifying it. So what we do is we need a function called an accessor function, which is also known as a getter function. That getter function can go in and out of the bucket and get all the private variables, because any function inside the bucket, inside the class, can access private variables. It's like they all live in the same bucket, they all live in the same castle or house, they can access everything from each other, Even if you're like, maybe not, it's not a nice thing, they can do it. And so what you need is somebody in that function to return. And how do you do that? Well, the function itself could also be private, by the way, but you make a public function. But that public function, you only make it a sort of a function that returns a value versus returning the location of the value, which could allow you to modify it. So it's going to be basically our messenger. Think of it like it brings you a copy of the value. That way you can't modify the original one. Okay. And so what does that look like in code? That's a rather simple task to do. What you need to do is, under the public category of variables and functions, you can go ahead and the typical name for them is get. So in this case, I would write a function called int get lines, maybe all lowercase. And that is basically, as the name implies, a function that's going to get us the value of lines. It doesn't need any parameters. And all it's really going to do is just return lines. And that's pretty much it. That's all the function's got to be. It's one line of code, but it's necessary because we cannot access lines directly. If we try to access lines directly, right here at the end of the code, cout lines, yeah, the easiest function ever written. It's not going to let us. It's going to say that, oh, is it line maybe? Oh, well, you need to put in the object name. So JJBA dot lines. I think that's the one that we made speak. Yeah. So now it says it's private. So that's why we can't do this. So now instead, we are going to call our public function called getLines. And that function is going to be called on the object of JJBA because remember, each of the objects has their own copy of a variable called lines. Because, you know, one anime might have a lot of lines and the other one may have less lines. So it actually matters which anime we're talking about. So each one has their own number of lines. And you can't just call it on just anime itself because that's just a class name. That's not an object. You know, ask yourself, what does that mean? Like, whose lines are we talking about? The JJBA or the Dragon Ball Z or SpongeBob? Like, which one? Right? So, yeah. In this case, we're going to say JJBA's lines. And just so you can see, we can also print out SpongeBob's lines. SpongeBob.lines. Not on web campus because it's too much effort, but I will share it on Discord at some point before the midterm. I basically just gotta like drag and drop, but you know, I don't want to have to do that daily. So maybe at the end of the week, if you guys remind me. Like, frankly, it's more of like you guys have to remind me to like zip this up. Like, literally, I have to go in here and, you know, create a zip there and then like move it up to my Dropbox and then open my Dropbox in Windows and then drag it over into Discord. So if you guys remind me of that, I'll do it on like tomorrow after the class. How about that? Just remind me. Otherwise, I'll do it before. Like last time, 135, I meant to do it like that, and I only did it one time before the final. So, yeah. Doing it on Canvas is more effort because then I have to upload it, and that actually takes more time. Oh yeah. Well, I gotta call the getLines function. So let's call the getLines function. So you're gonna do the member access operator, and you're gonna just basically call getLines. It doesn't take any parameters, but you do need to put the parentheses. So go ahead and do that. And then it compiles, you run it, and wow, why is that 58? That's a really big number. I don't think we have 50. Oh, I see. No. It's probably the 5 is coming from somewhere else, and then there's no line feed, so it's probably just concat. It looks like it's concatenated, but it's separate. I think that that's probably why. Yeah, see, the 5 is something else. So it's 8 and 0, so there's no lines. But if we put a line for SpongeBob dot good guy speaks, which would be SpongeBob, what does SpongeBob say? Welcome to the Krusty Krab Island. Oh, I know what he says. Yeah. Can you feel it, Mr. Krabs? Yeah. Okay. So there you go, 1. See, now it's 1. And if we put another one of those, because I think he doesn't he say that like repeatedly? Then there you go. Now it's 2. So can you feel the code now? So yeah, okay, cool. So that is basically what we just created called an accessor function or a getter function. Now, suppose that you wanted to have another variable that was private, but you wanted it to be settable. So what could be a good usage or an animate for that? Let's say the age. Yeah, the age. Let's say that we want to get the age of the good guy. Okay, so we're going to create a variable called good guy's age. Maybe like that. That looks kind of nice. And for now, yeah, sure, we'll initialize it like that. Why not? You'll see constructors, there's a more purist way of doing that. But for now, we'll do that. We'll say the good guy's age starts at 0, okay? However, you know, we have it as a private variable, right? Because here's the thing. Okay, let's put a bad situation first. So let's say we make it public, okay? You know, if it's public, I can go in and I can set SpongeBob's age. I have no idea how old SpongeBob is actually. So I can say SpongeBob's, good guy's age is equal to 15, or I don't know, probably 16. He has to be at least 16 because otherwise he'd be underage. It'd be child labor. So yeah, let's say he's 16. Okay, so that works fine, and I can see out it. You know, I can set the value, and then I can actually add it to my print cast. After I print out the good guy's name, I can go ahead and say space and then age, or good guy's age. Those Benjamin Buttons. He's a homeowner at 16. I mean, yeah, that's pretty good actually. Okay, so now you can see the number next to each of them. They're all set at 0 because we didn't set them initially, except for SpongeBob, which we did set, but we set it after we call print. So we can call print again on that. So print cast. So there you go, 16. Okay, so that's cool, but the problem is I can go in and set somebody to have a negative age. You know, and while that's just a visual error, suppose that I had some formula that was supposed to compute, you know, whether it's legal for them to work, or if we're casting the live action adaptation and we've got to hire someone to be SpongeBob, to play SpongeBob's role, we got to hire someone that's negative 16 years old. That's going to be a very hard catch, unless again, like some Benjamin Button thing. And so what we need to do is we need to control these kind of errors by either giving out a warning or simply not letting the user put a negative number and just setting it to 0. So what we can do is we can go ahead and make the variable private. However, our intention is for the user to be able to look at the variable and edit the variable, okay? So, okay, cool, let's set him at 34 years old then, all right? So, however, now because we made it private, this is gonna give us an error saying that SpongeBob's age is private. So what do we need to do? Well, we need to do a function that is going to be a messenger between the outside world and the bucket, who can set the variable that is private, which in this case is the age. So in this case, we want to have a function called set good guy's age. That's a good naming convention. You don't have to necessarily follow it, but the set part is very typical to have. It's kind of like somebody decided that's just a thing. So, you know, however, it doesn't have to be valid returning. Typically, your getters are valid returning with no parameters. Your setters, on the other hand, are void functions with one parameter or more, but typically one if you're just setting one variable. If you're setting multiple, I suppose it would be multiple parameters. So in this case, we do need a parameter of the same type of what we're setting, ideally. It doesn't have to be, but otherwise it's kind of like why. So in this case, it would be an integer, and you can do this. In fact, we will do this. You know, you can have the parameter here be the same name, but this causes some problems because remember your scoping rules. This function has its own scope. And then now we can talk about class scope as well. So in here, the current scope levels that we have, suppose that there was just out of nowhere a for loop in here, okay? Infinite for loop, bam, infinite for loop, okay. This is a scope. Line 19 is its own scope. well, technically 18, 19, and 20 are their own scope. From within that, although, no, actually, I would say that line 18 is its own little scope, because I could have int x in here, like I could do a for loop that does like int x, and then I could have an int x here, and that's like, they don't conflict. So, which is a horrible thing to do, actually. Although, I think that was a question in the 135 final in summer too. If Ferris and the other guy, or the other people that took the class are here, I think you guys had a question like that. And then it was something like x++ here. Yeah, I think that was actually a question. Like, what is the output of this code? Or something like that. And then I think it was like, I think this plus was here. It was something like that. And then I asked like cout x, because there was also an x up here. I think most people got this one wrong that actually had it in the test, because it was a little bit it was evil, I think. But yeah, so anyways, let's say that we have a scenario like this. The scope here is, this is its own scope. Then the for loop has its own sort of subscope, which is where the int x is. And then the next level of the scoping is the void function scope. And technically there's two layers of that. There's the void function, but also the scope up here as well. But usually they're the same, unless you declare a variable locally. But actually, no, in that case, I think you get an error. So yeah, from the for loop, you get to the function scope, and then that ends. And then from there, you have another scope that this is brand new. And that's going to be your class or struct scope. So that's this scope right here. And then from there, the next one's going to be the global scope in this specific scenario, okay? So what if you go ahead and do something like this? Well, now you got a little bit of a problem, because you can't do this. This is a problem, like, because what's end up happening here is this good guy, you're thinking, okay, this is this good guy, like the one from the parameter, and then this is the one from the class, right? That's what you think, like in the happy world place. But no, it actually is the same variable. They're all referring to this one. You can't access this one at all. It's like impossible to do unless you put something in front of it. And that something in front of it is actually the scope resolution operator. And then I believe it would be the class name like this. Now this is weird, because this is a confusing thing, because you're like, I am using the class name and then the variable name. And I've been spieling that you should not do that. Like when you do this, you do the object name and the class variable. But here, as you're writing the function, there is no object name. Where is it? Where did the function go? I lost the function, guy. Where did the function go? Oh, here. I didn't see it. I was like, what? I thought I was looking for the for loop still. Yeah, so basically, this is kind of required, because this is saying that we're talking about the class variable, and it's acceptable in this scenario, okay? It is not acceptable to have in main. It's only acceptable because this is a class function, okay? So yes, this is a very weird special case. Yes, you should be avoiding this. One way you can avoid this is just put a different name here like that, and then you don't need to do this part, and make the world a better place, essentially. To not confuse people that might not know that actually works. That will work just as fine, and it is so much easier to read. So while you should know that the other method is okay, like it's a valid thing to do, don't use it unless you have a reason to do that. You know, like there's a legitimate reason why you're intending to do the code like that, and that reason shouldn't be to make either yourself look smart or to make you look hardcore, because neither of those things will impress anybody. They'll just annoy your code developers, frankly. So yes, you know, don't do that kind of stuff. So anyways, okay, so this is our setter function. It doesn't have to be by value here. It could be by reference like that. However, if you do pass by reference, I would put a const here, since technically this function shouldn't mess with that g. It's just passed in. So yeah, you could do it like that, or you could just do the way that pass by value. It doesn't really matter. So okay, that solves part of the problem. In fact, now this code will actually compile if I go ahead and change this to say set good guy's age and then pass the 34. That will be okay, because I put the const in front of that, even though I passed by reference. That actually should compile. And then You can see now that in the print, you can see that the age is actually 34, which is good. However, you know, if that's your intention, just to be able to do that, to set things, but not to be able to read the value directly, only to read it to some sort of print statement, that's okay. But what if I needed to increase the age as a character and I was allowed to do that? Like, I'm allowed to change the age. Well, okay, suppose that you only wanted to allow them to increase the age. Okay, in that case, you don't need to give him access to the variable directly. You can do this with a setter function. But in this case, you know, right now you have a setter function that sets it like this. But suppose that you only needed to increase their age. You could create another setter function that could be something like void increase age, increase good guy age. No parameters, but simply call good guy age plus plus. Okay, and now every time I call this function, I will increase them by 1 year. So I can do basically SpongeBob increase good guy age, like that. Okay, and then if I call it again, this time I should print him as 35 years old. As you can see, I have control over what I can modify, partially because actually, you know, I have a set good guy age that can actually screw it up, because I could just like right now I can do negative 34, and then this will print out negative 33. You see? So, you know, okay, suppose that you only wanted to increase age, then you can just delete the function set good guy's age and only allow them to set that one time in your constructor, which we'll talk about. The other part is maybe you do want to have a set good guy age, but you want to limit what they can do to that. In that case, what you can do here is you can do any kind of error checking you want on G before you set it to good guy. So you can say, like, if G is less than 0, or yeah, less than 0, or equal to 0, I guess, if 0 is also kind of a bad age, then you can go ahead and basically see out error trying to set invalid age, and then maybe you at that point want to not change the age. Yeah, you can either not change the age at that point, or you can change it to something that is like an error state, like you can set it to 1 or just 0. Okay, otherwise then you can just basically change the age, which you have this in here. Technically you don't need the else clause, like that. I mean, this code will do the exact same code if it's the only code that's here as this, but if you do it like that, then you would need to put a return here. So I'd say that it's a little bit nicer to do this so that you don't have like a random return, because returns, you should treat returns like break statements, where they're used scarcely and only when necessary, because they can make your code a little bit more complicated to read. And that's not saying yes, value returning functions need return statements. What I'm saying is you should only ever have one return statement, and it should be at the end of the function, unless you're trying to unless you know any better, which is usually because you're trying to really make code short, and those returns help. But they always make the code harder to read. Okay, and when you get to CS326, they give you a big spiel about writability versus readability, and where sometimes the shortest code is not necessarily the best code because it can be hard to understand for others. And part of writing code is being able to understand the code that you've written later on, and it's a lot harder if you try to do some weird magic that only you know what happened, and harder to maintain. So anyways, so now I try to set the age to negative, and you can see here that it says error trying to set invalid age, and the age is positive still because it never changed it to negative 34. It's 1 because it started out at 0. That was like the value we initialized it to. Then I tried to set it to negative, so nothing changed, and then I increased it by 1. So that's why I see a 1 here. But see, now I do allow you to both read and write to the age, but I have control over what gets written there, and that way I can have a safer code and have to worry less about error checking every other function that deals with the age, because I can already expect that the age will be a valid value. So, you know, you could error check every single function that deals with age in your program. You could have all these checks about the negative values for ages and things like that. Or you could just prevent them from ever having a negative value in age and not have to worry about 1,000 of the same checks. That's the power that you gain by controlling a variable, by making it private and using a getter and a setter. So that's the main advantage of that. for not allowing people to modify things, and for the ones that you do allow them to modify, to not allow them to directly change it and control the change by sanitizing the input or to sanitizing the parameter that is passed in. Okay? How do we feel about that? Are we all good on that part? So now, one more thing I suppose that I want to talk about public and private is there is another one. There is protected, but that one we will talk about when we talk about inheritance, which is kind of like it's kind of like private with a twist, that, you know. But there is one thing though. So notice how I actually set the things to public and private. I use the word public and I use the word private. By default, if I don't put the word public or private, if I comment this out, everything inside a class will be private by default. And that's the big difference between class and struct. With a struct, if I change this word to struct, the entire program works exactly the same as if it's a class. But the only difference being that by default, it's public. It's like there's an imaginary word public right there. Okay, whereas with class, there's an imaginary private right there. Whether you're doing a class or a struct, you can, at your own convenience, switch it back and forth. All you gotta do is, like I did, you write the word public, and then you put a colon, and then you list things that are public. If at any time you want to switch over to private, all you do is you put in private. If you want to switch back to public, you can. Like I could literally switch back and forth every single line. Like I could do this, and I can go to private again. You know, obviously that's kind of unnecessarily just unnecessary to do that. You know, it's better to kind of list all publics and list all private in their own category. Although what I have seen is sometimes people have functions first in their classes, and then they put all the public functions and then all the private functions, and then they switch over to variables. They put all the public variables and then all the private variables. That I have seen, and I think that's acceptable to do that as well. But what is weird is if you just mix and match. Like here's a public function. Let me just throw in a private function. Now let me go back to a public function. Let me go to private. That's kind of like why, you know, it's not necessarily a syntax thing. It's just like a why would you do that? So what's the difference between class and struct if you can set private and public within them? Nothing else. That's it. That's the only difference that is there by default. So you might be thinking like, well, then it seems very pointless to have both. It's because C++ is backwards compatible with C code, and in C they use the word struct. So to maintain that compatibility, they kept the word struct in the C++ language. Otherwise, they would have just thrown it away, essentially. So in summary, public and private classes are for the security safety of the code you're writing. Yes, yeah, you can think of it security and safety-wise, basically to avoid people from doing dumb things. However, security is a big word because there are ways around it. Like you can hack into private variables with some of the methods that I'll show you. So, and it's not something that's like, oh my god, amazing hacker. No. There's very easy ways for me to actually like go into a private variable. So it's like what they call, honest man safety or security, where it's going to avoid accidents from accessing those things, but it's not going to stop malicious intents. You know, that's kind of what it is. But yes, the crack the vault, pointer arithmetic stuff. Basically, you know, if you have a variable x in there, and this is all private, right? So lines is private. So if I go in here and say SpongeBob dot x, you know, that lives somewhere. So what you do to get the address of that is you do the ampersand, and then from there you go ahead and you interpret cast yeah, okay, I think this will be okay. I think, and then you create this. Actually, no, you don't need any of that. All you have to do now is just do ++ of the address. I think maybe we need an ampersand there. Get the address of this. Okay, whatever. Get that address. See that. Okay, and then go ahead and do ptr++. I'm just trying to show you that it's not safe, to show you that I can actually access private variables. Okay, so there we go. That's giving you the address. So then all you gotta do now is basically cout that. And then let me put some line feeds here and some line feeds there. That's giving me an address. Dereference. Never mind. I'm rusty a little bit with the pointer stuff. There we go. Okay, so we got a 2 out of that. So then, since that works, let me go ahead and set ptr to be not big number there. And then what was next to it? Was there 2 of them? Good guys ratio. So ++. I need another ++ in here. So ptr++, ptr++. Okay. So now, H is private. It should be safe. But guess what? SpongeBob now has 54,000 years of age. So even though we set the age of of SpongeBob to be private, which means that nobody should, it's secure, right? Nobody can change the age now because we have our setter and getter and all those things, right? Yeah, no, look at that. Bam, you got hacked. Now you got 54,000 years of age, right? We just hacked life. Now you can live infinity time. So you will learn how to do this when we talk about pointers. But for now, I just wanted to demonstrate you so that you don't get a false sense of security, okay? So yes, that was the only reason why I showed you that, essentially. What I did, if you're curious, is all I did is I got the address of the variable x, which was just a random variable. I know I put that variable myself, but I could have used these variables, but it was just easier to get this one directly. And then I used pointer arithmetics to get to the location of where that variable is. Albeit, I needed to know the blueprint of the class to be able to do that. Otherwise, I would have to just be kind of snoping around, testing different things. But still, it's not secure, right? So don't assume that this is secure for like hack proof or something. No, it's an honest man security system. It's just like a const. It's meant to avoid you from making mistakes. Okay, because if somebody's doing this, they have malicious intent. They're not doing it because they're nice. And so because they're doing this, it means that that at that point, you can't stop them. Life finds a way, hackers find a way. I mean, look today with the thing we're talking on Discord. Twitter got hacked, right, with the Bitcoin stuff. So yeah, can't do much about that. So all right. Anyways, so that's private and protected. Sorry, public and private. Let's talk about constructors. Yeah, let's just do constructors next, actually, since that's another thing we covered in 135. So I might as well just cover it now and get over with it. So, so far I've been initializing variables inside of the class by setting equals here. But this is actually something that was added in C++ 11. It's convenient, but it's not part of the original 98 C++ standard. Back in the day, how did they initialize variables? They used constructors. And constructors are still very, very popular because, frankly, it's a better way to initialize things than this. I am not a fan of doing it this way, actually. But I did that just quick and dirty way. What is a constructor? Okay, so when you create an object, that gets allocated somewhere in memory and bam, you got all the variables in there, right? But it's a very convenient thing if we had some sort of functionality in C++ that allowed us to initialize those variables. Because, one of the things that hopefully they crammed into your head in 135 is you should always initialize your variables because that avoids like half of the problems that you may end up with, okay? If you don't initialize your variables, you're playing with fire, especially if you actually just throw stuff at, you try to use them as a counter or something and assume that it's set at 0, right? So because initializing is very important, and when we talk about dynamic allocation, that's also kind of an important place to allocate things. Constructors were made for that purpose alone, to be able to initialize things when you create an instance of a class. So when you do something like anime DBZ or anime SpongeBob or anime GBA, that is a time when we would like everything to be initialized. And so by default, C++ gives you what is known as a default constructor, which is just sort of an empty constructor with nothing in it really. But you can change that to initialize as you wish, basically. And so how do you do that? It's a little weird of a function that you add in inside of your class with the same name as the class name. So like anime. And then you got your parentheses and your curly brackets. That's your constructor. As is now, is a default constructor. Your constructor, you can have more than one constructor in the class, just like you can have more than one function with the same name. It kind of works the same way as function overloading. You know, the only difference being that either the parameters have to be a different amount of them or different parameter types. So like one of them could be an integer, one of them could be a string, one of them have 2 integers in it, and so on. And one of them can have no parentheses, no parameters in it, like this one. So with the default parameter, what can I do? Well, this is the place where I would do this kind of initialization. So this is where I would go ahead and, okay, copying and pasting, bad idea. Do something like lines equals 0 or good guys age equals 0. This kind of initialization is going to be what is the OG way in C++, like what they first did it before the other method was available. But that will do essentially the same thing as this. This thing will automatically get called when you go ahead and do anime SpongeBob. That is happening in the background. If you want to test that, you can go ahead and put a print statement here saying constructing. And then you will see that somewhere in the beginning of the program, we see that we're constructing get printed. And that actually will match the location on where we declare the variables. So here's anime and SpongeBob, and in between we had a print. As you can see, we have the first constructing, then we have a print, and then we have the second constructing. So that indeed does match. We actually have 4 of them. Why do we have 4? I thought we had only 3 things in here. Oh no, because we did the vector thing, that's why. So yeah, essentially that's how you initialize variables. That's pretty much it. Now, suppose that you wanted to have another constructor where you passed in all of the stuff here, all of the names and whatnot. You can do that. You just have basically a constructor with 4 strings in it. Now, you can also go ahead and do the same thing that we did before. So you can go ahead and do name equals A. What is the second one? Good guy equals B. And then you can do bad guy equals C. And then, what's the last one? Sidekick? Yeah, sidekick equals D. And that is going to, but don't forget, actually, we also got to initialize the lines and the good guys. So you need to do that in both because only one of the constructors is going to get a call. It'll pick the one with the closest parameters, basically, as the constructor itself, but only one will be called. So how do I actually call this constructor that I just made? If I want to call the default one, I just put the class name and then the identifier and then no parentheses. Don't do this. I thought you could do that, but you cannot. It'll actually give you an error. So if what you're trying to do is use default constructor, don't throw anything at it. If, on the other hand, you wish to use the other constructor we made, then just pass in the 4 strings. So in this case, we'd actually be passing in these strings. So we can actually get rid of this code and just move it over here. The only I suppose tricky part here is make sure you pass them in the right order. Could you have a function that does the same thing that the constructor does? Absolutely. However, again, you may not want people to modify these names once they've been set the first time. So we could actually go ahead and make these all private and then have a getter function so they can get the names, but they can never change them again. Once they've created the anime, they had to pass in the right names. They can never have a name change after that. As you can see, the code will still have the same oh, I forgot that was the name. Oh yeah, this is the same character names as that. Okay, so yeah, that's pretty much how constructors work. There is one more thing I would like to show you about constructors, and let's show it with this one. There is another way that you can initialize variables. It's kind of weird. I'm not sure what the official name of this is, inline initialization or something, but you can actually put the variable names up here separated by commas like this. So you no longer need to have them in here. And then you put parentheses like if they were functions. And inside of that, you put the value that you're initializing with, which in this case is 0 for both. It's kind of weird, but it's actually less writing, so I recommend that you do it. The only trick with this is you have to use the same ordering that they're declared in. Otherwise, you get like a warning, which is not an error, but it's a warning, and I don't like receiving warnings. So yeah, like I'll show you. If I move the lines after the good guys, I recall it gives me a warning saying like, this is not a good idea. What are you doing? But it compiles and it works. Oh, it didn't give me a warning this time. Maybe because I have that in there. I don't know. Did I not save? I don't know. I seem to recall it giving me a warning if I throw things out of order. So it's not giving me the warning now, but it has in the past. So I would just be safe and put them in the order. Okay. I don't remember why, but it did give me a warning. I'm like 99% sure that was a thing. So anyways, just put the same order that you actually declare them in. So like lines and good guys, lines and good guys. Don't do good guys and then lines. You can also use the same method for passing in parameters where, oh, maybe, but I rarely use wall. Like I don't ever use wall when I create the assignments. That's why they have bugs sometimes. I don't actually test them. So yeah. Like I could literally go and do wall in the CSGO assignment and it would be like a billion different warnings probably. Like I bet you so hard. I almost want to do that. But no, I'll do that later. But yeah, so anyways, you can do this with parameters as well. So let's go ahead and do that with the anime one. So let's do it just with one variable. So maybe let's do it with the sidekick. You do your colon and you do sidekick, and then that's in D, so you could do something like that. Maybe the warning has to do with the order of these parameters. No, that wouldn't have. That makes sense. I don't know. I don't remember honestly. But yeah, there you go. That works as well. So you can mix and match. You can use initialization this way, and you can also initialize this way. And this is kind of cool because look, this is the name of the variable, and then this is the parameter that I'm setting the variable with, and that is actually this parameter here. So this is doing the same thing as if I had sidekicks equal D here. So notice that this is less writing than this, and there's also technically less lines of code. So if you're really like OCD about making your code really small, this is one way that you can save a lot of lines. And I do know that I think this method is technically faster than this, but yet again, I'm pretty sure the compiler optimizes that nowadays, so I wouldn't worry too much about doing it for that reason. Just to remind you, when you're writing functions like this, technically those are inline functions, and they're supposed to be faster because you actually copy the code in each instance of the call, whereas when you do them outside, they're regular functions. Just to refresh you on how to put them outside, let's go ahead and move this one outside. Leave a prototype there. Paste it outside. And then set the class name here. One more one. Let's do one more. Let's move this one outside. How about that? Oh, actually, ooh, no, because I don't actually remember how to do the weird thing with this. Ooh, yeah, actually, I can't remember if this will work. I feel like I have always problems moving this outside. You can move a constructor outside, but the issue is when they have the things like that. So like, I don't know if this will compile. I don't think it would actually. Yeah, and then if I remove these, oh, there we go, it compiled. Okay, so that's how you do that. Cool. Okay, so you just leave the parameters like this, but you can still do this down here. Okay, cool. I thought that wouldn't compile for a second, but hey, it will compile, so that's good. So yeah, what I want to show you with that is that you can move a constructor outside. You just again put the class name, and then you put the name of the class again because it's a constructor, and then parentheses. It's kind of weird if it's syntax. Historically, I feel like a lot of people miss that. You know, when I ask them that on test, how to declare a constructor outside the class, they forget the anime part, or they put like void in there or something. What lines does? What it does is the same thing as if I had inside the constructor lines equals 0. It's just initializing this variable with whatever is inside of the parentheses, which is a 0. So it's initializing it at 0. So it's doing the exact same thing as this. It's just a different way of doing it. Again, it's shorthand. So shorthands are good. They save time. Other questions? Finally, I'm going to briefly mention the Destructor. Again, that is mostly used for dynamic allocation, so we will definitely revisit the Constructor and Destructor. And that's okay, because it kind of looks like a function, so don't feel bad that you don't know that. So how do you do a Destructor? It's almost the same as the Constructor. There's only one Destructor ever. There's no different types. Like with Constructors, you can have as many as you want. Destructor is only one, and it's written the same way as the Constructor with the anime and the parentheses. And then you write the body of the Constructor. But there is one tiny difference, and that is that here you put a tilde. That's like the little squiggly thing next to the 1 and the tab key. That is the Destructor. And that's just kind of a thing. You always put that in front of all of them, all the Destructors. And this runs, the official terminology from when this runs is when the object goes out of scope. What that means is if you have an object inside of a function, it's going to go out of scope when the function ends. When we talk about dynamic allocation, there are ways for you to basically destroy the object beforehand. But until then, just know that the Destructor will run when the object goes out of scope. Now, we have no real use of the Destructor right now. We could technically set like variables to 0 at this point, but it's pointless because we're getting rid of this object already. We're throwing it away. So there's no reason for us to clean up. I guess that's the thing about programming. We're just messy. We just use variables and we never worry about cleaning them up because we assume, correctly so, that the next person that gets that memory location will initialize their variables and not end up with garbage. So, yeah. As you can see, that compiles is fine, but you see a lot of little destructors called at the end of that. That's because when the main function finishes, all the little anime objects that we made have to be destroyed. And so we need to destroy the anime. And so essentially we are calling the Destructor of all of them. So that would be DBZ, that's 1, SpongeBob 2, JBA, JJBA 3, Anime Temp 4, and then I guess when we do pushback onto the vector, that's the 5th one. So yeah, that would be the 5. Yes, destroy the anime. Okay, so that takes care of Constructor, Destructor, setters, getters, public, private. Let's talk about static. So, shall we go into a clean example? Because this code base is kind of getting big. I'll keep it in the folder 1. We'll call it anime SQL. Okay, so now that we did the anime SQL, we're going to clean up a bunch of it. So we'll keep. We'll make a bunch of it from scrap. Yeah. Yeah. Okay. So, okay. Before we even talk about functions in terms of static, let's talk about it in terms of. I'm sorry. Before we talk about classes in terms of static, let's talk about functions in terms of static. Okay. So, suppose that I have a function called int okay? And so this function's job is going to be to spam okay? That's just its own job. That's the only thing, okay? So now, and maybe you know, yeah, we'll do that, okay? Cool. To prove a point, I'm gonna create a variable here, you know, set 5 to it. Then I will include that variable there. Actually, a 4 in leet code is the same for an A, so we will go ahead and use that for the last letter of yeah. So like that. And then I'm going to increase that by 1. And that will not do anything because that's where the function ends. And actually, this doesn't need to be int, it can be void. Okay, so let's go ahead and call the function we just made. Okay, so it works. And see, that looks like an A, doesn't it? In LeetCode, the A4, yeah, it's like a little side A. You guys see that? You know, I feel like LeetCode kind of died in the last 10 years. Sort of sad, but yeah. Oh, LeetSpeak, not LeetCode. But anyways, so cool. This works just fine. So now, here's the thing. Let's call the function again. What do you expect to see? In fact, actually, better yet, let's use a little for loop for this. Okay, and then we got an S, and now we can just define that here. So let's do it. It runs 6 times, okay? So bam, we got it 6 times. Notice that each time we have a 4 in there, okay? We could also put a 3 in here, and then do x++, and we should still get a 4. Right? Okay. Suppose that we wanted to count how many times this function has been called. One of the ways that we could do it, one of the bad ways that we can do it, so you can make a global variable called count, set it to 0, and then in here we could do count ++, and then at the end of this function we could do cout count. And it works. We get a 6 there. We could change this to 8. And it works too, right? Okay. However, global variables are a bad thing, right? You know, you get slapped in the face if you use a global variable, essentially. So what can we do then? We could pass a parameter like an int count and then increase that by 1. We could also actually just have a count in here that says like count ++. But that will work for this kind of scenario here. But suppose that this IIF function was used all over your program in other functions, in other classes, everywhere. Like there could be a function foo, you know, that calls within the code, it calls III in it. And so if we do this method here, whereas the global variable would work for this method, doing it with the counter here, if somewhere in the code you have foo, then the count will be off. Because it's not counting it, right? It's only counting the loop. Count. Count was not declaring the scope. Oh, I forgot to get rid of it from here. Yeah. Right, so we get 8, but technically we got 2, 4, 6, 8, 9, okay? Because of the foo. So global variable is a solution, but this is not. So is there a way that we could keep track of a variable that persists between different function calls, that it always that is associated to the function? The answer is yes, and that is known as a static variable. I can create a variable here called static int count equals 0, and then I could increase my count in here, and you will see that nothing happens right now other than it compiles and runs. But now I can figure out what this count is if I find a way to kind of return it to main. So I could go ahead and either put this as an int here and just return my count. In this case, do count ++ maybe to avoid issues here with the count being off by 1. And then I could add foos all I want. I could have another IIL loop in there. But whenever I'm ready to see what count is, I can just go ahead and say cout. Yeah. 19. Is that correct? Well, let's figure this out. What is S? S is 8. So we got two loops that run 8 times each. So that's 16. Then we got two foos, which is 18. And then we have one more, which is the cout, which is 19. So there you go. It is indeed correct. In fact, we could actually add it to here and see that happening by putting a little space in here and then couting the count. As you can see, every time that the function gets called, count continues to increase. And you're like, wait a second, you know, when your code runs, you're like, okay, we got and then we set this count to 0, and then we do stuff, we print it, and so on. But every time you run the function, it's setting it to 0, right? Well, it would be if I got rid of the word static. In that case, all I would see is a bunch of 1s and 0s. Actually, a bunch of 0s and then a 1 at the end of the thing. See? 0, 0, 0, 0, and then a 1 at the end. But with the magical word of static, this thing works. So, why does this work? What happens is the following. When you create a function call, you know, the operating system allocates space on what is known as the stack or heap, actually. Stack, yeah, on the stack. I believe it's on the stack. Actually, no, it's on the heap. It's on the heap. Yeah, I think it's on the heap. So it allocates and puts the function call on the heap. And what it does is it allocates variables for all of the parameters in your function, and then fills them up with stuff, does the computations, saves the return value back to where the function was called from, and then throws it away from the heap, and then it shrinks back down. I think it's a heap. It might be the stack. I have to think. It has to be the heap. Yeah, it has to be the heap. So anyways, there is a modification to this idea when you have a static variable. That is kept on the stack, actually, for sure. And what happens is, this static variable, only one instance of it exists for all function calls. So whereas each individual function call in this example has their own value of x, you know, because that's a local variable, they don't each have a count in them. They would if I had removed the word static, but instead, all they have is a reference to the one and only copy of count that is shared between all function calls. And so it's kind of like the parties variable, okay? And it's very useful when you want to have persistent data or data persistence between different function calls. Very useful for things like counters, but in general, just comes in quite handy for a lot of uses. So that's how static variables work with functions, and they work very similarly with classes, actually. But before I jump into the classes example, I want to make sure that you guys understand the function example. So, everybody get that? Sorry, I got a message on Discord. I was wondering if it was related to class, but it is apparently not. So, yeah. So, anyways, what does static int do again? So, static int basically says that there's, you know, whereas normally each function call has their own copy of variables and their own local variables, static is one shared variable between all function calls. So, you know, pictures help. I got my function, and when I call that function in memory, I get a little slot that has parameters and local variables. And so, you know, it has an x value here, and if I had a normal count without the static, it would have a count variable. So if I call the function again, it would have another x and another count. With a static variable, instead of having a lone copy of count, it only has a reference to the one and only version of count, which is kept somewhere else in memory. And so if they want to read or modify, they all read from the one instance of count. Okay? X, yeah, each one has their own copy of x. They don't share that. But this is shared between function calls. Okay? Yes. Variable persistence, I suppose. And function can end and come back. So it's kind of like a global in that sense, but it's hidden to only the function. Only the function can access it. That's why actually I needed to return it to be able to access it. I couldn't access it in main, you know, without returning it in one of the function calls. Technically, they all return it, but I don't use it. Okay, so this will make more sense once we extend the idea to a class. Classes can also have static variables. And just like with functions, there's only one between different function calls, static class variables or static class member variables will only be one instance amongst all the objects that share it. So whereas each object has their own variables in it, so in the anime example, each one has a sidekick, each one has a good guy, each one has a bad guy, each one has a line number, they will all share one variable if it's static, and that one it will be whatever we want to do it. So what do we want to do it for that? For that example, well, let's go back to the example now and add it in. Well, I would say that we can have a count of how many animes exist. Okay, anime count. That's a good one actually. So it can be an integer, although technically I suppose it would be nice to make it an unsigned integer since you can't have negative counts. So might as well practice some unsigned integer usage since we never do that. And then we're gonna call it anime count. Okay? However, it's static. So we'll do this. However, I don't think if you do it this way, I don't remember if that'll let you compile. Maybe in 11 it will, but if you do it like that, okay, so those let you compile either way. So yeah, so you can set it up this way, and then bam, now you have a static integer, unsigned integer. Okay, unsigned, if you don't remember, it means that it only works for positive numbers, not negative numbers. So you move the spectrum from like negative 2 billion to positive 2 billion, from 0 to 4 billion, that range. So now, if I was to go ahead and print out SpongeBob's anime count, well, actually, we need to do more interesting to it. So we have our anime count, but now let's increase it every time we create an anime. Where can we increase it? Well, we can increase it in the constructor. That seems like a good place because every time the constructor gets called means that we've created a new anime object. So it seems like the ideal place to just do anime count plus plus. However, we have two constructors, so make sure you add it to both. Only one constructor will ever get called, so that's okay. Okay, so now that we have that, we can print out the anime count. And yes, you can make it private just the same way you can make them public. I'm just making it public so I can quickly access it here. Where'd it go? SpongeBob anime count and line. Oh, I see. I'm still running the example. Okay. So it doesn't allow you. See, okay. So there we go. So it doesn't allow you to initialize it in there. Okay, that's what I thought, but then it was letting me, so I was like, I guess it's letting me. So yeah, it can initialize it in here. If you try to run it like that, then scary things happen because it's not initialized. So we gotta initialize it outside the class. So to do that, we can go ahead and do unsigned int anime count. I don't think we need the word static in there, and then put the word anime in front of it like that. You can't see that, can you? Yeah, here we go. Now you can see it. Unsigned int anime count, like that. And there we go. Okay, cool. That's what I thought. For a second, I was weird. Yeah, we were compiling accidentally the other file, but now we're okay. So yeah, because I wonder why it wasn't giving us an error. So I was like, okay. Oh my god, we're still doing the other file. Okay, there we go. Okay, cool. So now we've created, and here it is. Here's the 4. it obviously is printing before the destructors because of the destructors is the last thing that's going to run in this case. So we can say anime created for our, what is it called? Funimation Studio or something? That's like the people that broadcast the anime, I think. So anime script for Funimation Studio 4. Okay? And so if we want to go ahead and actually, instead of printing SpongeBob, suppose that we printed JJB, what is it? JGBA. You would see that that would also print out 4. And also if we printed out Dragon Ball Z's. Even if we printed out the temporary one that we made, anime temp, that would also print out 4. So it's always printing 4 because it's a static variable and they all share the same one. So they all have a reference to the one static variable locations. There's only one anime count, whereas each object has the name and the good guy and line and all that. All of them share one single variable integer, which has the anime count. And they can all modify it, and how they can modify it is anywhere. But in our case, we only modified it in the constructor. We increased it by 1 there, because that's only the real usage of it that we could do. If there could be other usages, but this is the one that we thought of, okay? We could also decrease it if we wanted to, technically. And the only trick to this is that you can't do that inline initialization like this, whereas you could do that with the other variables. And also, you if you try to initialize it in the constructor like this, you're just going to be resetting it every single time, and then your thing is not going to work. It's going to go to 1 all the time because you're resetting it essentially. So you can't initialize it in a constructor, and you can't initialize it in inline the class like with the equal 0. So your only option, and this is kind of weird and it's a unique thing to static variables, is you do it outside. This looks like if you're just initializing a variable in the global scope, but that's just the way you do it. In fact, you know, it's public right now, right? So that's okay to do that. But if I made it private, so let me move it to the private area of the code around here. And then I compiled and ran it. This tells me it's private because I'm doing it over here. So let me just comment out the couting part. But then if I compile and run it again, it compiles and runs. And you should be asking yourself why I'm allowed to modify a private variable. Because that's what I'm doing here. I am modifying a variable that's a static variable, but it's private. I can't do that. If I try to do this with good guys, age, it will not let me. It will tell me that it's private. And in fact, once I do that modification elsewhere in the program, I tried to see out that variable and it told me it was private. So it is actually private. Well, it turns out that static variables require you to initialize them outside the class. And furthermore, because of that, this is an exception to the rule with private variables that you are allowed one time only right beneath the class to initialize it. It's a one-time exception thing. And how you do that is you put the class name, not object names, but the class name, scope resolution operator, and then the name of the static variable, and then your initialization value here. Okay, so it's a very special case that violates everything I've been telling you so far. But rules are meant to be broken, right? So here's a scenario of that. So whether it's public or private, I'm going to move it back to public again so I don't have to do a getter for my printing. But whether it's public or private, you can initialize it outside the class. You have to initialize it outside the class using that same syntax. Okay? So unfortunately, that's one of the things that a lot of people have a hard time with, and I really want to emphasize because historically in the past, people in 326, they start talking about statics from the point of view of actually all that stack and heap stuff. That's when they really go over that stuff. And the difference between a static function call and a non-static function call, because you can also have static functions and non-static functions, which I'm going to show you in a second, is that they have a this pointer, which we'll also talk about eventually. And static function calls do not have a this pointer at the address 0. The address 0 is going to be the first variable, whereas a static function, a non-static function does have a this pointer in address 0, and then address 1 is going to be the variables. A static function does not have a this pointer, so address 0 has the first variable. This will all make sense when you take 226, but I will talk about this pointer and stuff like that later on. So, but the thing is, people seem to go to find a way to pass all these classes without understanding statics, and that shouldn't happen. So make sure you guys actually understand statics, and I guarantee you 100% that I will ask you statics in the test, like a lot about the statics, because I wanna have a copy of those tests with me. So that when you guys say 226, if you guys forget static and you're like, we never learned static in 202, then I'm going to be like, here's my test. And they even got, if they got the question wrong, then fair enough. Maybe you didn't learn it. But if you got it right on the question and you forget by the time you take 226, then I will protect myself by having your test with me. So, yes, that's the big thing about static. So make sure you understand it. So I'm going to go over it one more time. Static variables. There's only one instance of a static variable for all objects, whereas regular variables, member variables, each object has their own copy of them, which has its own data. Static variables, there's only one copy for all objects. It is shared. It's the community variable per se. Furthermore, when you declare a static variable, you have to put the keyword static. In fact, actually, I think syntactically, you can put it after the word int, and I think this works. I think, maybe not. No, see, it does work. It's just weird. You can throw static there before or after. Put it before, otherwise it just looks weird. Like int static, it's just kind of weird. But yeah, see, it compiled. But yeah, put the word static, put the data type, integer, float, double, could be another class actually, whatever, and then put the identifier. That's how you make a static variable. But then to initialize it, you have to do it outside the class. You put the data type, you put the class name, not an object name, not JJBA or DBZ or SpongeBob. You put anime. Then you put the scope resolution operator. Then you put the name of the variable, and then you set the value to whatever you want to initialize it with. That's going to be what is going to start off when the program runs. Okay. Furthermore, because it is not part of any object, it's a community variable. It's not associated with any object, so you can actually call that variable without a specific object being referenced. So I can actually call this this way. I can call it with the name of the class and the scope resolution operator and the name of the variable. I think, but I will test it before I claim for sure that will also work. Nope, it does not. Okay, I guess that one doesn't work, but this will work. Okay. So yes, you can call a static variable this way. You can also call it with the individual object's name, but even more than that, those static variables are declared when your program runs, whether or not you have declared an object of that class. So even before I declare my first ever object of anime DBZ, I can actually see out that static variable's contents, which should be 0 at this point. Right there, 0. So I have not created a single object of the anime type, but I already have a variable existing in memory called anime count, which is the community variable. That's because it's independent of any object, so it has to be allocated at that time before objects are made. Otherwise, you'd have to kind of wait until the first one is made, and it'd be a mess. So they just, for all sense and purposes, it's a global variable. GIF wrapped per se. In fact, some languages like C#, the only way that you can declare a global variable is by making a public static variable. Public static. If it was private, then you can't access it this way, right? You need a getter and a setter. But and then that actually brings up another point. You can have static functions inside of classes, and it gets a little complicated if you go to Java with all the static stuff. So, but I believe you can do something like this. While you can have a void foo in here, you can also have a static void foo, and that will compile. But things get weird here, because here I can actually see out my my static variable, I can see out anime count. You know, that will work. That should work fine. However, I think if I recall correctly, this will not work fine. I can't see out local variables. Yes. Okay? Oh, well, did I spell it right? No, I did not. So, before I claim that, let me make sure it's spelled. Aha. So, yay. I remember my thing, my C++ correctly. So, I get an error if I try. So, whereas a normal function, I can access all the variables I want in the class, you know? In this function, because it's a static class member function, I get an error if I try to access any non-static variables. I get an error saying invalid use of member anime name and static member function declared here. Why? Can you guys think of why this would be a problem if I could access it? My dog is licking my hand. But yeah, any guesses as to why it's actually a problem if I could, if it allowed me to do that? That's right, you're correct. It is independent of the object. So the static function is like the static variable. It's independent of any object. It's its own thing. For all intents and purposes, you could think of this almost like a non-class function that has extra privileges to access some private some potentially static variables that could be private. So yes, I actually can call this function in my main. Okay, hold on. There's like saliva in my. No one I guess saliva on my keyboard. Puppy. Okay. What is it called? Foo? I could call foo like this here. And if I get rid of the oh shit, I just opened latex by accident. Close latex. If I get rid of this one that gives errors and I compile this, I can go to the top and I can see here the 0. This 0 is coming from inside the function. And the first 0 is from the anime count part. The second one is from the foo. So, yeah. Essentially, that static function doesn't also need to be connected to a specific object. You could call it with an object. I could do like SpongeBob.foo. But again, it's a static function and it's really only meant to deal with static variables. So a static class function only deals with static class variables. Otherwise, you run into problems because you can't call the function like this, which again is separate from any object and would cause conflict if it was supposed to ask the name to be like, what name are we talking about, right? So yeah, puppy. So any questions about statics now? I think now we've covered about everything involving statics for C++ that I can think of, at least at this level. I don't think that even beyond this level there's more to it. Let's see what else we got. We covered statics, we covered public and private, we covered constructor and destructor, setters and getters. That's pretty much everything. I mean, I will go on. The class will not end. But that was all that I at least wanted to cover. So that's why if you have questions, I can take the time to answer them for this. Otherwise, I will move on into talking about more stuff. So I'll wait a minute to see if anybody has any questions. All right, nobody has questions, I suppose. So, okay. Oh, we got something. Isn't there the advantage that you could pass arguments in that don't require object instantiation? Isn't there an advantage that you could pass arguments in that don't require? Not sure what you're trying to say with that, but I'm trying to see, what do you mean by pass arguments that don't require object instantiation? You have to expand on that to see. I'm not sure what you're referring to. I mean, one of the usages of having a static function in a class is like, for example, if you want a function that is sort of just useful in general, but not necessarily dealing with the class variables, but you still want it to be sort of in the namespace of the class and not in some sort of global namespace, that could be one usage of it. I don't know if maybe that's what you're referring to. Yes. Okay. Now I kind of just want to talk about a little bit, and you can ask and post more questions if they come up, but I kind of want to give you sort of, I don't know how would you describe this, a motivation for coding in this system with classes and objects, right? Like, because you might initially be resistant to, okay, there we go, it's cool. Initially, you could be resistant to say like, I don't like coding with objects. I just want to code everything in main, or not put functions and objects together. I don't believe in the bucket idea, right? And so, you know, it could be a valid mentality, I suppose, but I want to try to tell you why switching over to object-oriented programming is a potentially useful thing as a new programmer to learn and to sort of expand their ability to write code. And that comes with the idea of abstraction, okay? So abstraction is basically the idea of separating a design from the details of how design works, okay? So for example, if I'm trying to make a class for a car, and I have an engine in it, and this engine, you know, it has to work, but I don't need to know how it works. As long as I put an engine, I can let somebody else worry about that. But if it's part of my class, I know that my car has an engine. Okay, so if I have a class called car and there's an engine in it, that's all I need to know. And in programming, abstraction is a very useful thing, because you, as a programmer, even in 1.35, used functions from a library that you probably didn't know how they were implemented. You know, we've used the size function for strings for sure. You used some of the CMAT stuff like absolute value and POW. You could kind of picture how POW is implemented, like exponents, you know, a couple of ways. Maybe it's a loop. Maybe there's some bit shifting going on. Maybe there's some dark magic involved. For all you know, it could be any of these things. You as a developer don't need to know that. All you need to know is a POW, you feed it in this, it does some black magic to it, and you get the exponent value back. That's it. That is abstraction. And that is useful, because if your job is not to figure out how POW works, that could be somebody else's job to maintain the function called POW, update it, you know, if there's any bugs, they take care of it. All you know is you gotta call POW and you're good to go. And so that's very powerful, because it's almost like when they tell you in the business, like you want to what's that word? It starts with a D. You want to give duties to other people. You guys help me out here. What's the you want to delegate. Yeah, delegate. Thank you. Yeah, you want to delegate your duties to other people, right? You don't want to try to control the entire business yourself. You want to delegate. And that's kind of what you're doing with abstraction, you know? You basically telling, like, okay, I'm going to worry about working on this part of the problem, and anything beneath me can be done by other people. And you yourself might be the result of somebody delegating something else. Maybe somebody's doing an entire car company with multiple different cars, and all you're working on is a specific model, and you're working on that level. Beneath you, people are working on the specific engines that you're using, and above you, they're working on the entire company as multiple cars. You're part of a big, well-oiled machine per se. Somebody's delegating to you, and you're delegating to somebody else, and you do part of the work. And abstraction and the concept between classes allow you to do that. That's one of the big powers of it. And now when I'm going to start to talk to you about what inheritance is and composition, you will see the great power of doing that. Now, we had somebody says, it seems like not using OOP is harder to work in teams, which makes really large projects. Yes, it is. It is really hard to work in teams if you're not using it. Although, you know, if you're using functional programming and things like that, things kind of vary. But then again, why would you be using that in a normal programming environment unless it's kind of like math or special? But yeah. You call the electrician to work on your electrical problems, right? You don't need to. You can try to read a manual, but it's going to be so much faster for you to let them deal with it, especially in a company. You know, if your job in a company is to code and the toilet stops working, you're not going to go in there and like try to fix the toilet. You got to work on your code. You know, you let the people that work in cleaning services to take care of the toilet, right? You know, that's kind of a weird example, but I don't know. That's the first thing that came to my head. So when you're designing a class, you know, one of the useful ways to communicate to other people what their tasks are going to be and what your task is going to be is what is known as a UML diagram. So that's kind of what I lead into here. UML, I believe, stands for Universal Modeling Language or Model Language. Google could prove that. I have here in the notes somewhere. UML. And what you're describing with the UML, I don't know, I think it's Universal Model Language. You know, Google it. I'm sure there's a Wikipedia article on it. Is you're using it to define what is known as an abstract data type. Not beta type, but data type here. And what is an abstract data type? It's a data type that separates logical properties from implementation details. So, separates logical properties from implementation details. Okay? Logical from implementation. So, you know, pile function gives me the square root or the exponent and 2 to the 5th power or whatever. You know, I know what it does, and I don't care how it actually gets coded in, like how that actually works. You know, I don't need to know, basically. So all I know is it works, right? And so when you're designing a class, one of the things that you need to do is you need to think of that sort of abstract layer of like what I'm trying to do and what are the features. So let's pick an idea that we're trying to implement. And last time around when I did this, I did it on animals. So this time I don't want to use animals. The animate thing is kind of tricky because I want to have functionality. So do you guys have anything that you want me to do? Maybe this could be a good thing. I'm looking around and seeing. Yeah, Star Wars ships. Yeah, okay, let's do ship. Because car is just like overdone. Like car is literally like the first thing you see on Google when you talk about UMLs and abstract stuff. Because I mean, I even said it, like engine and car, right? It's just so much overdone that I'm trying to really avoid the car example. So we'll do ships, which is going to be the same thing as car, but at least it'll be different. That way, if you guys end up Googling for extra help, you don't end up with the car example and you're like, well, that doesn't help because it's the same example that I already got. So we'll do it with ship, okay? So we got a ship. Let's say we're working on a ship. Now, this ship could be the Millennium Falcon. It could also be an X-Wing. It could be a B-Wing. I think that's a ship name. There's the Y-Wing. I know that one's definitely a ship name. And there could be also some dark side things like a TIE fighter, a Star Destroyer. Although that's kind of too big of a ship. That's kind of its own category. So these are more of like frigates or combat ships. Slave 1, yeah. What's the name of the Jedi Starfighter? Is it just Jedi Starfighter, I guess? That's too long of a name. Okay, good enough. Yeah, that's good enough. Okay, so what we need to do is we need to abstract what each of the... So what we're trying to do is we're trying to like develop a video game, for example, okay? And the video game that we're developing is a kind of like Star Wars Rogue Squadron or one of those like ship fighting games. Which, by the way, there's one coming out by EA called, I think, Squadron, actually, in like a month or two. That's gonna be cool. But anyways, so we're trying to develop it, right? So what we need to do is we need to be able to have all these features that the ships have, but obviously they're not all the same ship because otherwise the user's gonna get bored if they all fly the same. You want to have some differences on them, right? And so we need to have the different features that they have and what they can do, like the functionalities that they have and things like that. So with the UML, that's kind of what we're going to do. So how does a UML work? Let me show you first how UML diagram works and then how we can apply it to our problem. So the UML, you usually put a little box and then there's two sections to the box, okay? The top and the bottom. Now, I kind of made this shorter than this one, but it doesn't really matter. Either one could be bigger. The top one, you typically list the variable names. And that's kind of going to be the data itself that you contain. Now, what can be that data in our case? Well, fuel supply, if we care about that. It could also be stat based. So the range of the ship, the maximum speed, that is actually a pretty good one. Maneuverability, if that's a thing, maybe that's a rating, a class rating in the game. When you're trying to balance the ships out, one of them might have higher speed, but lower maneuverability, or vice versa. Health, HP, weapons, yes. So here, let's write these down. So HP, speed, weapons. That's going to be a good example when we talk about aggregation, actually. This is going to get like a multi-day example probably now. So you got weapons, speed, maneuverability. That's a long-term maneuverability. Speed, and maybe one more. What is something that would be useful in the game to have? Speed, by the way, is really max speed, so I should put that in there. Acceleration, that's a good one too, because that's different than speed. Capacity could be useful depending I mean, most games, you're single player, but sure, we'll put capacity as a little feature. Although I don't think that's something that we'll need to balance for the game, unless the game was like some sort of RTS that was like transporting groups of people across the map, and then you had to balance it because you didn't want a ship that could transport like 100 people super fast. You want to be a slow ship. So sure, capacity could actually be a thing. Payload, let's call it payload too. Payload in general. That'll cover basically capacity and other things. So let's go with that. Otherwise, it's going to take us like 10 years to code this. So let's kind of stick with just that for now, okay? So, okay. So those are the kind of variables that you want to keep track of. Those are the hard data points that are going to be unique to each ship. Since we talked about statics, let's talk about what things they can share. One of the things that we kind of want to have individual to each object is going to be perhaps an entity ID. So that's going to be a unique identifier for every single object. Now, if you have 2 TIE fighters, you want each of them to have a unique identifier. So we can achieve that by giving it an ID. And that's going to be useful because when we spawn them all on the map, then if there's 2 TIE fighters, you might want to have them each have a unique ID associated to the object itself. But that's going to be a normal variable. But to be able to actually get the unique ID working, we can actually use a static counter. And that way, every time that we create an object, we can increase the counter just like we were doing with the example, and essentially use that to have no 2 ships have the same ID. Okay, so that's going to be useful for us. I don't think we need any more variables. We could obviously make more, but that's going to be good enough. Okay, now that's all of the hard data that we need. The next thing that we need to think about is the functionality that we want, or potentially if some of the data is private because we don't want people to mess around with these stats, which more than likely that'll be the case for a lot of it. Although we may allow flexibility like customization, player they could add something to it and that increases the acceleration or so on. Like they change the engine, like Call of Duty games with all the gun accessories, that kind of thing. So that actually would be cool in the fighter game, like a flying game. Yeah, but oh well. So yeah, so because of that, we may need some getters and setters for that. So that's something that we can think about now, or we can think about later. For now, we're just going to do it for one of them. We're going to do that for the ID, because that's one that we definitely want to make private. That's going to be one of the features that we have, is that we have the ID, but we don't want people to mess with the ID because it's unique, and we don't want them to accidentally change it. So it would make sense to make it private, but we are going to need a function to access the ID in case we need to figure it out. With the constructor, we'll take care of setting it to the right value, but we want to be able to access it, okay? And so for that, we are going to need some kind of get ID function. So our functionality, I'll put over here, is something like get ID, okay? So yeah, we'll go ahead and do that. Now, what other functionality can we have in our ship? Let's keep it small. Let's put some examples. And that's going to be, for example, we want it to be able to be destroyed, like when it gets shot down. So we can say a destroy function, which will take care of destroying the ship. Another one we can have is perhaps to take off, right? Land. Now, these might have parameters, but now I'm not putting anything in it. Another one is take damage. Yeah, take damage. Take damage is a good one because take damage is actually going to be a function that is going to modify our variables, right? It might lower the HP, you know? We could also have a function called accelerate, which increases the current speed, but we don't have a current speed on this. We just have a max speed. But yeah, I think those are good enough for now. So the question is, how do we actually do a UML to represent all of this? Well, on one side here we have the variables. On the side down here we have the functionality. So these are going to be your functions. The other thing that is useful to say, which I've kind of been doing it so far, is whether variables are public or private. So you can do that in a UML by using the following symbols. I believe plus and minus. Minus represents private and plus represents public. So let's say that the take damage function requires a parameter, which is going to be the amount of damage that the ship takes. And then get ID is a value returning function because it needs to return the ID. Destroy and take off and land don't have any parameters. Yeah, okay, we'll do that. So now, how do we actually put this inside the UML? How do we do that? Is quite simple once you know the technique. First, list all your variables, and then if they're public, put a plus in front of it. If they're private, put a minus in front of it. So in this case, it makes sense to also make the static count private, but and then we will make the HP private as well. And then we'll leave the rest public just to make it easy. We can make them private later, but we'll do that, okay? So go ahead and just list all of the variables that are public. I mean, you can actually mix and match, but I would kind of list them in a nice order. So list all the public variables first and all the private ones. And this is why I didn't want to have a million things, because now I got to copy each of them. I'm going to abbreviate maneuverability to be just man. Ax for acceleration, cap for capacity, pay for payload. Actually, let's just get rid of payload. And then we got our private variables, which are HP. So we put a minus in front of it. So minus HP, minus ID, and minus count. Okay? But there's more to it, because the UML can also tell us the data type. And so what you do is you can put the data type after the variable. This is strictly a way to communicate to other people what the variables are. So this isn't necessarily coding related, but yeah. Why is it not switching back? I don't know how to switch back to the normal chat. Like I lost my ability to write messages now. Oh, there we go. Okay, cool. So yeah, okay. So from here on, we the way that we put the type of the variable is we put a colon. This is just sort of the syntax of UML diagrams. And then you're going to put the data type. So what is max speed? That makes sense. Let's let's make that a double. Why not? Weapons is going to be a string because it's going to keep the weapon names. Max speed. What is math? Oh, maneuverability. That'll make an integer because it'll be a small number. Acceleration. We'll also make that an integer because it'll be like acceleration 1 through 10. 10 being the fastest ships and 1 being the slowest to accelerate. And capacity, it'll be an integer as well. And then HP will be also an integer, 0 to 100. ID can be an unsigned integer since we don't need negative numbers. And count can also be an unsigned integer. However, we need to put the word static in there as well. So just throw in static in here as well for the count. Okay, we kind of screwed up the rectangle, but it's a rectangle, okay? So that's the first part of it. By the way, if we had an array, so suppose that we had a weapons array, because you can have more than one weapon. then you can just do that. So now we have a string array. Okay, so we'll do it like there's multiple weapons. So yes, it's a rectangle with a tail. And now I made it worse. Why? Come on. Okay. So from there we're gonna go ahead and list our functionalities. So let me actually kind of copy paste so I don't have to zoom out so much and you can actually read it. Okay, so there's our functionality. So how do we add functions here? You still use a plus and minus for public and private. So the ID is going to be all numbers, no characters. Nope, we're just going to do numbers because then we can use a counter to make them unique each time. So like we have ID 5 is just like ship 5 and then they increase the count. So the next ship we make is ship 6. It's a lot easier to do it that way. We could use characters, but we don't expect them to be that many ships. So ID numbers is fine. Again, it's kind of like a social security number. It's just a number. It's easier to just give it out like that, okay? Don't post your social security numbers, please. I mean, you could, but DM them to me, and then also DM me your credit card information, and then we'll talk. No, okay. So, anyways, so for the functions, we're gonna make them all public. We could make a private function, but what could be useful to be as a private function? Nothing here that really I see it being as a maybe like destroy. Yeah, let's do destroy as a private function. So destroy only gets called when the HP gets to 0. So it's only really going to be called by a function like take damage. So it'll be internal. So yeah, we'll make that one private. And again, we are going to code this probably next time. If I could code it on my own and then show it to you, but I think we can code it quick enough next time. So yeah, let's go ahead and list out our. Let's start with that function so I don't forget that it's private. So what you do is you put the minus because it's going to be private, and then it's going to be the destroy function that's private. So you put the name of the function, then you put the parameters just like you would with a normal like function prototype, and then see if I don't forget anything. You put the return type afterwards, and whether it's a constant or not. So in this case, all there is no const to it, so we would just go ahead and put void. That, okay? And that's the syntax that you're going to use. So it's kind of like the variables. You just flip it backwards. For the other ones, like get ID, that one is public. So public get ID, no parameters, but it does return an integer. Destroy, we already listed. Take off, it's public. No parameters. Oh yeah, okay. We do have one that takes damage. So that has parameters, so you can see that. So we got takeoff, and then we got land. There's also void. And then finally we have take damage, which does have a parameter. So you would just list the parameter like that. I don't think you have to put a ampersand there to signify if you pass by reference or not. But I'll check back on that. You might. I would put it actually because it tells you more about what you're doing, so why not? In this case, we don't pass by reference. We don't need to. But yeah, so there we go. So I got them all now. So 245, 245. Yep, and that was the original file that we have. So there we go. Now we have what is the UML, and oh, by the way, I guess I didn't actually put this in here, but typically you have a little box up here with the name of the class, so which is called ship type. We'll call it that. Sounds official. Let's get rid of this and we have it up there. And there you go. We have created a UML. Now I can give this to my developer and say, go do it. And then he can go ahead and do what we'll do the next step, which will be making the class blueprint. And then once he does that, he can tell his underlings per se, like, okay, you take care of doing land, you take care of doing take damage, you take care of doing get ID, and I'll do the destroy one, for example. Okay, so yes, it is like an outline of a class. So because you're trying to do this whole abstraction idea, we want to develop all the functionality as by name, and then we will worry about how we actually implement that. So yes, it's a good way to outline your classes and to plan ahead of time. So for the assignment 3, when you get that, this will be a useful thing to kind of understand. But we still got to do assignment 1 and 2. So yeah, that's chain of command. Divide and conquer is another term for that. But yeah, we shall be coding that next time. I don't want to start coding it with 5 minutes left, because that will not end well. But does anybody have any questions about the material? Good lecture. All right, cool, great. I enjoyed it. We actually covered quite a bit. So next time we will implement this, and then we will go ahead and actually expand what we did, because we are going to be using inheritance and composition. We will use inheritance to develop subtypes of ships that we can probably do, and then aggregation and composition we will do for the weapon class. We'll modify it. We'll make a weapon class, and then we'll use that inside. Yeah. Where's Padme? She was here a lot. She was literally here for like 60% of the class, but then she left. So she was definitely here. I'm glad she left, because I was getting kind of hot. So yes. Now we have questions on the assignment. For the assignment, if we're going to refer to an algorithm for sorting, are you saying we can't follow it? You can follow it. What you can't do is just copy and paste the code. There's a difference between like, this is how selection sort works, versus like, let me just copy and paste the Geeks for Geeks implementation. So yes, it's a thin gray line that you have to be careful. Well, 3 more minutes if you guys have any other quick questions. So we can follow the algorithm, just not copy and paste the pre-made code for sorting. Yes, for the situation with sorting, yes. You cannot use strFind because I want you to practice searching text. So the 2 functions you can't use are strFind and strsort, which basically you can't use sorting and finding. You have to code those. Erase you can use, but I'm not sure what purpose it would be useful for. Like, I don't think that actually is useful. But if you want to use it, that's fine. I don't think you ever really have to erase anything in the text. But I guess if you do some weird form of searching or sorting with erase, I guess, yeah, that's okay. The green screen makes my eye look weird. Like, I'm missing an eye. Yeah, you can use bubble sort. Frankly, I prefer selection because you're only sorting 10 items. Like, you're just searching for the top 10 tweets. So it's a modification of selection sort. But I use exit from cstdlib. Is that okay? Ooh, that's okay, but why are you using that? That sounds bad coding practice in general. If you're using it for error checking, that's okay, but you shouldn't ever really exit out like that from programs. Only if you have a major error. And oh, hello Padme, welcome back. So yeah, you can use it, but I would discourage you from using it. Oh, hello. She's like, the time has come to end class and play fetch. So that's why she came. Oh. Well, if there's nothing else, then I guess that's the end of class, guys. Like I said, you can always message me on Discord. And I hope that the TA, because I did see some people in there with the TA that was helping out today from 2:30 to 5:30 to 5 p.m. right before class started. So hopefully he did a good job, and he'll be available again on Monday so that he can help you guys out more. Cool. In that case, I shall see you tomorrow for more coding. Have a good day, everybody, and see you all.